Hey, what's up guys? Hope you're all doing great. Today I'm breaking down a key concept in Java programming aggregation. It's one of those fundamental ideas that can really help you write better, more efficient code. And guess what? I'm gonna do it in just 3 minutes, so let's dive right in. Buckle up because this is going to be a quick but informative ride. First off, what is aggregation? It's a term you'll hear a lot in object-oriented programming. Simply put, aggregation is a form of association that represents a has-a relationship between two classes. This means one class contains a reference to another class. Imagine you have a class called and another called. The class can have an object as one of its fields, a has-a. This means that the class is a part of the class but can exist independently. So, even if the object is deleted, the object can still exist on its own. Okay, let me show you a quick example. This will make it clearer. Here's a simple class with some attributes like and Java public class address. Now let's create a class that uses this as one of its fields. Java public class person, but in this example is not dependent on the class. They are associated, but one can exist without the other. If we delete the object can still exist. This is a key point to remember. This is the main difference between aggregation and composition, where in composition, the contained object cannot exist independently. In composition, the lifecycle of the contained object is tied to the lifecycle of the container object. So why is aggregation useful? Well, it promotes a modular design. It makes your code more reusable and easier to manage. You can change one part of your code without affecting other parts. It also mirrors real-world relationships, making your code more intuitive and easier to understand. For example, a car engine, but the engine can exist separately from the car. Now, let's talk about implementation. How do you actually use aggregation in your Java code? When you're working with aggregation in Java, you typically use a constructor to pass the aggregated object, just like in our class example. This ensures that the object is properly initialized when you create an object. This keeps your code clean and ensures that all necessary objects are initialized properly. It also makes your code easier to read and maintain. Finally, here's a quick tip. Always remember to check for nulls when dealing with aggregated objects to avoid those pesky null pointer exceptions. This is a common pitfall that can lead to runtime errors. You can do this using simple null checks, or by using Java's optional class for added safety. The optional class provides a way to handle null values more gracefully. And there you have it. Aggregation in Java, all wrapped up in under 3 minutes. I hope this quick guide has helped you understand the concept better. If you found this helpful, don't forget to hit that like button and subscribe for more tech content. Your support helps us create more valuable content for you. Catch you in the next one. Peace, stay curious and keep coding. See you soon.